Hi guys, so today what we're going to look at is a quiz that a lot of you guys missed that's still going to be really important for you for your final exam, which again is going to be right after you guys get back from prom. So this was a two-question quiz, and what it's looking at is it's looking at two histograms, and it's saying the histograms show the household size, which is talking about the number of people in a household for the year shown below. So I'm going to talk you through this more than I'm going to actually write about it. So it says compare the distribution. So in order to compare two distributions, what you need to be thinking about is CUSS. You need to think about using comparative language as well as context. So household size, comparative language, more than, less than, everything. So the way you're scored on this is essentially correct, partially correct, and incorrect. So first thing, center. Well, if we look at both of these, they both have this skewed shape, except if you look at 1950, it looks like this skew comes a little bit later, maybe towards like 5 or 6, whereas this one comes a little bit lower, maybe towards 3 people in a house. So what we're going to say is we're going to say that. So it looks like the mean number of people in a household in 1950 is less, so this is the comparative language, than the mean number in 2000. Okay. Anything unusual? Nope. Shape, the distributions of number of people in a house, you can also say household size, are similar. That's comparative language. Are similar in 1950 and 2000. Let's just scroll down a little bit here. Okay. Both are skewed right. And then the other thing we need to talk about the spread. So if you look at the range, this goes from about 12 down, and this goes from about 14 down. So we can say the range of household size is larger in 2000 than in 1950. Did I say that right? Nope, I think I said it backwards. In 1950 than in 2000. The range is larger in 1950. Okay, part B. So make sure you have that context and that comparative language. Part B. A researcher wants to use the data to construct a confidence interval to estimate the change in mean. Remember, mean means t if you're talking about a test. They're talking about a two-sample t procedure, meaning test or interval. In this case, it's saying interval. Explain whether the conditions are met. So when we talk about t or anything, we're always talking about randomness, independence, and then for t, it's nearly normal. So for us, let's see. They did say random samples up at the top. Okay. N is greater than 500, so we do know that they're both nearly normal. Okay, and then we need to make sure that the samples are independent of each other. That's the other thing we need to state. And up here it says independent random samples. So by using that, that really does check our conditions. So we have random samples for both groups. They're independent of each other. I'm not talking about independence within groups in the 10% condition. They're independent of each other. Houses in 1950 and 2000. And they're both nearly normal since the sample's bigger than 500. So we could say yes, they are met. Okay, the question on the back now is giving you 8 apartments are trying to be picked because we're going to carpet. We're going to replace carpet in a building. This is apartments and these are the floors. There's 9 floors. The asterisk says that there's kids. So some apartments have kids, some don't. They're sort of spread out throughout. So for convenience, the apartment owner wants to use a cluster sample. Cluster means you pick all from some, in which the floors are clusters. So they're even telling you the floors are clusters. So select 8 apartments. Describe a process. So that means you need to describe how you could actually do this, okay, and make it repeatable. I should be able to repeat it when I read it. Describe a process. We always need randomness, and it says for randomly selecting. So what we're going to do, if the clusters are the floors, then we're going to say put numbers 1 through 9 in a hat. These represent the floors. Represent each floor. Well, now we know each floor has 4 apartments and we need a total of 8. So what are we going to do? Pick 2. Pick 2 numbers out. Those 2 floors will have their apartments carpeted. 4 on each, so we're good to go. Part B says an alternative sampling method would be to select stratified. Stratified means some from all, where strata are apartments with and without. So we would group them into apartments with kids and apartments without. We still want a sample size of 8. They might include 2 with kids and 6 without. In the context of the situation, give one statistical advantage. Why would we want this? Why would we want a stratified sample? And make sure, again, we always use context. Why would we want a stratified? Well, this makes sure, this ensures that we have a sample of apartments with and without kids. Well, why do we want that? Well, we're talking about carpeting. So maybe carpeting will get worn down fast if we have kids versus if we don't. And so we should say that. That's why this is an advantage. So we can then compare carpet wear in both types of apartments. If we took a stratified sample, we might not get that. We might get a sample where all of the apartments have kids or all of them don't. C says now you want to do a different sampling method. We're not concerned about apartments. We just need to select a simple random sample. This just means our most basic names in a hat. So here what we would do is we would put all apartment numbers in a hat. We're told we want to select 8, so select 8 numbers. These carpets, or these apartments, will be the ones that get carpet. Notice I'm using the context. We're talking about carpet here. If you did not read this question entirely before listening to this video, please make sure you go back and read the whole thing because it's talking about she's wanting to decide whether to replace the the carpet in the apartments. If you did not finish this quiz, please make sure that you do. And if you don't understand anything, please make sure that you see me so we can go over it.